Before we get started, let's take a quick look at the Inventor HSM Express user interface. Like Inventor, all of the commands you will use can be accessed from the CAM tab of the ribbon toolbar, or via a right-click shortcut menu on the CAM browser. The CAM browser lists all of the job setups and operations used to machine this part. Let's edit an operation and review the layout. Operations are organized into 5 logical tabs: tooling, geometry, heights including clearances and cutting depths, passes, where you will refine the strategy, and linking, where entry, exit, and rapid movements are controlled. With that said, we're ready to work through the process of programming a part similar to the one you'll be presented with in MANIA. Let's work through this first example. The first thing you'll need to do is define the job setup. So on the CAM tab of the ribbon toolbar, click Setup. To define the model, I'm going to activate the model icon, choose only the part we want to machine, and then move to the Stock Definition tab. In this case, for the stock definition, we'll define the side offset as 0.125 inches, top as 50 thousandths, and bottom 0.2 inches. Finally, we want to set the working coordinate system at the top corner 3. With the working coordinate system set, we can click OK and our job setup has been created. First, what we're going to do is qualify the top of the part using a facing operation. So click the face icon on the CAM tab and then open the tool library. Select a 3/4 inch tool and click OK. The facing operation is automatically created. Next, we'll rough out the 3 pockets using a high-speed roughing strategy called 2D adaptive clearing. Open the tool library and select the 1/4 inch tool we want to use for this operation. On the Geometry tab, click the bottom edges of the 3 pockets and accept each one using the mini toolbar. Now click OK and the roughing operation is complete. Note, Inventor HSM Express automatically set the top of the pockets at the top of the stock and the depth of the operation at the edges we selected, before calculating the most efficient way to remove the material. Now we're ready to finish the pockets. This time, use the 2D pocket strategy so we can apply a finish pass to the walls of the pocket. We're using the same tool, so we can move to the Geometry tab and select those bottom 3 edges. On the Passes tab, apply a finish pass and uncheck the stock to leave. Click OK and the finish pass is created. Now we need to rough and finish the outside of the part. Again, to rough the outside of the part, we're going to use our 2D adaptive clearing strategy and the same 1/4 inch tool. On the Geometry tab, we want to select the outside chain of the part and uncheck machine cavities, because we machine on the outside of this chain instead of on the inside. On the previous operation, our depths were automatically defined because we selected the edges at the depth we wanted to machine to. However, in this case the contour was not selected at the machining depth. So move to the Heights tab, and in the bottom dropdown, define the bottom of the operation at from model bottom instead of from the contour selected. Additionally, we want to machine past the bottom of the part by 10 thousandths of an inch. So enter a bottom offset value of -0.01. Finally, move to the Passes tab and zero out the axial stock to leave before clicking OK to produce the operation. To finish the outside of the part, we're going to use a 2D contour. We're using the same 1/4 inch tool, and on the Geometry tab, we can select the same chain. Make sure the arrow is on the outside of the contour, indicating we're machining around the outside of that chain, and move on to the Heights tab where we can define the bottom from the model bottom. For this finishing pass, we're going to machine beyond the bottom of the part by 5 thousandths of an inch. So enter an offset value of -0.005. Click OK and the finishing operation is complete. Next, we're going to break all of the sharp edges on this part using the chamfering option of the 2D contouring operation. Open the tool library and select our 1/4" chamfering tool. Activate the Geometry tab and select the bottom edge of each of the chamfers. With the edges selected, move to the Passes tab where you'll note the chamfering option has automatically been activated because we're using a tool capable of producing a chamfer. There's no need for a chamfer width because we're working with edges that have already been chamfered using Inventor. However, we will enter the tip offset value of 20/1000 of an inch, so we're not machining with the tip of our tool. Click OK, and the chamfering operation is produced. We're almost done machining the part. The last task is to machine the holes. For this example, we want to machine 4 632 holes with a spot drill, drill, and tapping operations. Let's get started. Click the drill icon, open the library, and select the 1/4" spot drill. Activate the Geometry tab and select the conical face of one of the spots. When a conical face is selected, Inventor HSM Express sets the depth of the operation correctly so that the tip of the drills produces the conical face. Use Select Same Diameter to find all the other holes within the part that are the same size. Click OK, and the spot drilling operation is complete. Now let's do our top drilling operation. Open the library and select the number 24 drill. Move to the Geometry tab and select the tap drill hole modeled in Inventor. By checking Select Same Diameter, we're going to select all of the holes, and by checking Merge Hole Segments, the tap drilling operation will start at the top of the part and finish with compensation for the tip of the cutter to produce the entire hole. We can move to the Passes tab to change this operation to a chip breaking cycle and click OK. The final operation is going to be the tapping operation. So select Drilling, activate the library, and select the 6/32 tab. Activate the Geometry tab and simply select the cylindrical face of the tapped hole. Use Select Same Diameter and click OK. Because we selected a tap, the operation was automatically defined as a tapping operation. We're now ready to run simulation to verify that all the operations have been produced correctly. Select the Setup in the CAM browser, and by right-clicking, you can simulate all of the operations within the job. I personally hide my toolpaths and show the stock as transparent. With your options set, we can run the simulation. In this case, I'm going to speed up the simulation, and we verified that all the necessary operations have been produced for this setup. You've completed part 1. So you've been issued a design change. Let's work through the processes of updating the part and toolpaths. You'll find that by leveraging the parametric abilities of Autodesk Inventor, this process is going to be quick and painless. Select an outside face of the part, edit the sketch, and change the width of the part to 3.5 inches, and accept. Finally, in the model browser, unsuppress the added features, and when we return to the CAM browser, we can regenerate the toolpaths. Let's conclude with generating the setup sheet, saved with your name, and post-process the code. Use the generic post, enter your program name as 0001, and click Post. Click Save, and when the NC editor opens, move to the Backplot tab, start the backplot, and you're finished.